It didn't take long after the first steam engine wheezed its way into life at the dawning of the age of technology for designers to realise that their art was one of compromise. And no matter what the mechanical device may be, all aspects of its design and operation are the result of compromise on the part of the designers and engineers who conceived it. Now, never is that more true than in the case of automotive suspensions. And if you think about the fact that by far the best relationship of a tyre to the road is vertical to the road, and that suspensions are designed in such a way that as the body of the car heels due to side forces in a corner, the tyres assume angles other than vertical to the road, you can see where the problems arise. Now, design have spent hundreds of thousands of hours and millions of dollars over the years in endeavouring to design suspension systems which keep the body of the car as parallel to the surface of the road as possible. And the device which has just been fitted to my car, which is called a G-force stabiliser, has effectively put all of those dollars and hours to waste, because what it does is address the problem from the other end and ensure that the body of the car stays parallel with the road regardless of the side force. Now, it's called a G-force stabiliser, and I said a little while ago, in fact, it was fitted to my car in December of 1997. It's now August of 1998, and I've had the pleasure of driving my old 60 series Land Cruiser as effectively a research and development mode for the last 9 months or so, and the results are truly amazing. Now, we're just approaching a roundabout here, and I'll drive at a speed of around about 55 kilometres an hour, which is the speed at which we tested this unit a few weeks ago on this exact same roundabout. Now, I'll just accelerate up to 55 kilometres an hour, which is about all our cameraman, Spinksy, in the back can handle as far as side forces are concerned. And I'm sure that you can see, looking through the windscreen, that the body has remained effectively level. And it really is quite an eerie experience to go around in a car which is renowned for its body roll, around a corner as tight as this, as fast as this, and find that the body stays effectively level with the road. Far more graphically than that, have a look at these shots of my vehicle driven around the same roundabout at the same speed with the G-force stabiliser disabled. Now, this is a truly magnificent technological innovation. It's all Australian once again, which makes me proud. And as I said, I've had the opportunity to live with it intimately over the last 9 months. I know exactly how it works. I've driven the car with it disconnected, and I've been astonished at how much effect it has. Its technology is just as spectacular as its performance, and we're going to come back in future weeks and show you in detail just how the G-force stabiliser works. Last week we gave you a little preliminary glimpse at the G-force active body roll control device as designed and invented in Australia. And I have to say that that segment generated more interest than anything I can remember in recent years on Leisure World. And it's nice to know that you're watching and listening, and it's nice to see that people understand the ramifications of technology such as this. Now, just to reiterate for those who weren't watching last week, the G-force stabiliser active body roll control system is a hydraulically driven system which controls the roll of the body of any car, whether it be four-wheel drive or standard sedan or station wagon or whatever, under the side forces that are experienced during cornering. The advantages are huge. It keeps the tyres squarely on the road. It minimises the tendency of the axles to steer the car and destabilise the car through corners. And it also keeps the suspension fully active regardless of how quickly you go through a corner. Now, I said last week that we would show you the technology. Let's take a look at a truly fascinating subject. Now, before we look at the details of the G-force, let's just take a look at the way suspensions in general work. The design engineers have to compromise between softness of ride and control of body roll under side forces which are experienced during cornering. And that means that when those side forces are applied to a suspension which is acceptably soft when it's going in a straight line, the body rolls. When that happens, In the case of semi-elliptical springs, which are curved under normal circumstances, the springs flatten out on the outside of the corner and curve a little more on the inside, which alters the wheelbase on both sides of the car. It lengthens it on the outside of the corner and it shortens it on the inside, which causes a phenomenon known as axle steer. Now, a secondary effect of the suspension being flattened out on the side of the car that is to the outside of the corner is that it is no longer active. If the car experiences a bump, the suspension is likely to bottom pretty well immediately, and this further exacerbates the effects of destabilising forces on the car because the suspension is simply unable to cope with them. So the designers of this system set about designing a control unit which was capable of anticipating the inputs and reacting before or as those inputs began. They turned away from electronics and invented a hydraulically based control unit which is capable of anticipating the incoming forces and reacting in exactly the right time to totally neutralise body roll in the vehicle. The wonderful thing about the hydraulic control unit is that it's fundamentally simple in its basic design and in its operation. This means that it's easy to manufacture, it is compact so it can be fitted under the bonnet of most vehicles, and it is also extremely reliable, meaning that maintenance periods are very lengthy. Now let's see how it works. The hydraulic control unit is mounted under the bonnet of the motor car rigidly and is fed by a standard power steering pump which is driven by the belt circuit on the front of the engine. There is a hydraulic reservoir and hydraulic lines go to specially designed hydraulic rams which are mounted on the left-hand end of stiffened anti-roll bars on the front and rear axles of the vehicle. The locations of these rams can be varied according to the requirements of individual vehicles. The moment the vehicle diverts from straight ahead and enters a corner, and therefore centrifugal side loads are introduced, the hydraulic central processing unit senses those side loads and applies hydraulic pressure in the appropriate direction to the rams mounted to the anti-roll bar. The hydraulic central processing unit incorporates a hydraulic circuit within the valve which takes care of the damping of the movement of the valve. Now, the remarkable thing about this valve is that for the first time in the history of hydraulic engineering, it is capable of giving a proportional output. This means that the greater the side force, the greater the force the valve will exert, and as the side force varies up and down in its magnitude, the valve reacts instantaneously to those variations in side force. Now, I emphasise that the reaction of this valve is infinitely variable and is totally non-linear. Now, as I said a little earlier, I've had a G-force stabiliser fitted to my 60 series Landcruiser for the past 7 months, and in the course of shooting the footage for this video, we disabled the unit and I drove the car around a roundabout at 50 kilometres an hour, and I was really quite astonished at just how far the body rolled. We reactivated the G-force stabiliser and it was back to the car that I had become used to. Now, as I've already mentioned, there are significant and obvious advantages to having a G-force stabiliser fitted to any motor vehicle. They maintain the suspension neutral point, allowing the suspension to fully articulate during hard cornering. It eliminates axle steer and bump steer during cornering. The car remains online and stable. It enhances the overall handling characteristics of the vehicle, making it safer and more comfortable to drive. It minimises the centre of gravity shift outwards and therefore makes the vehicle inherently more stable whilst cornering. It maintains the tyre footprint and therefore the adhesion on the road. It minimises wear and tear on the suspension, on the tyres and on the steering circuit of the vehicle. It positively affects all aspects of the vehicle performance and behaviour, including the fuel consumption, and it reduces motion sickness for passengers in the vehicle. Now, the benefits of this are ongoing and they flow right through to the basic design philosophy and approach of engineers when they're designing motor vehicles. The G-force stabiliser will allow design engineers to incorporate softer spring rates in their vehicles and also longer suspension travel, making vehicles overall much more comfortable in all aspects of driving. The benefits extend to the fact that this system is self-contained and self-reliant, and all it requires is the top-up of the hydraulic fluid at regular and quite long intervals. So there it is. It's truly fascinating technology. It's all Australian and we should be proud of it. It has a huge potential world export market which it will realise very, very shortly. And I have to say, as I said a little earlier, when we disconnected it on my car, I just couldn't believe how effective it is because I'd gotten used to it over the last 7 or 8 months. Now, if you would like to know more about it, and there are kits for the G-force stabiliser on the market, available on the market now. There are fitting centres up and down the east coast of Australia. If you would like more information about the G-force, call Ron Atkins on 0419 375 624 and he'll give you all the information.
Suspension engineers have, in the past, needed to compromise between good handling and ride comfort in order to provide an adequate motor vehicle suspension system. The unique G-force stabiliser system reacts instantaneously to preload the sway bars upon sensing weight transfer caused by lateral acceleration. This results in precise handling and a very stable vehicle. The system comprises of 2 sway bars whose diameters have been increased by 50%. 2 twin-acting hydraulic cylinders which replace 2 fixed struts on the sway bar linkage. Oil is supplied to these cylinders via an additional power steering pump, and the pressure is regulated by a control module which is sensitive to lateral acceleration and not vertical acceleration, and utilises a hydraulic feedback system to allow proportional pressure delivery. Because the control module is activated by a pendulum, it negates the need for electronic sensing devices. The module has been extensively tested, traversing all types of terrain, and has exceeded 200,000 kilometres without significant wear. The cylinders utilise the latest in manufacturing technology, including Teflon seals, urethane bushes, honed tubes, and chrome shafts are built to last the life of the vehicle. Small flow sensitive dump valves are used to short-circuit cylinder oil flow when the system is in its neutral position. This minimises vertical acceleration impulses being transmitted to sprung mass via sway bars. The G-force stabiliser system eliminates fishtailing, eliminates front and rear axle steerage, reduces tyre wear and reduces suspension wear. The system can be fitted to any four-wheel drive vehicle, including new and older models. Patents for the G-force stabiliser have been granted in Australia, Europe, the United States of America, with Japan pending. A typical Range Rover kit consists of 2 sway bars, 2 cylinders, control module, 1 power steering pump, 11 high-pressure hoses, 1 dump valve, oil reservoir, 5 mounting brackets, 2 fixed struts, plus necessary bolts, clips, saddles, etc. A 30-second television commercial has been produced to which can be easily tagged with local distributors to assist with marketing.
With a G-force stabiliser, this unique pendulum valve senses any change in road stance and reacts instantly. With the G-force stabiliser, you get increased passenger comfort and safety, improved vehicle control, reduced tyre wear, reduced suspension wear. Experience the very latest in suspension technology. Ask Latrobe Suspensions Moe or the Bairnsdale Wheel Alignment Centre about the G-force stabiliser.
For further inquiries about the G-force stabiliser system, contact Wayne Somerville at Latrobe Suspensions, Market Street, Moe, or Active Suspension Developments.